Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. Everyone, this is Terry VanNoy, and thanks for watching these instructional math videos from my channel on YouTube, Math Class with Terry V. And if you like what you see, give me a call at that toll-free number on the top of the screen, or visit my website, fill out a form to show you're interested. I can send you more information. Thanks for watching, and let's go on to today's lesson. Today we're going to talk about perfect square trinomials, and actually what to do to factor a perfect square trinomial. Well, it's a special pattern in factoring that you learn, and we kind of need to go backwards here. We need to figure out what happens when we square a binomial and what kind of trinomial do we get. And what I want to do is show you some patterns. That way we can talk about how you factor something when it is a perfect square trinomial. So take a look at my examples on the left here. We have x plus 1 quantity squared. We're going to multiply that out using the FOIL method, and then we'll figure out if there's a pattern to that trinomial that we get. We also have x minus 3 quantity squared, 2y plus 8 quantity squared, and 5k minus 4 quantity squared. Well, the first step is to remember that when you're squaring something, you're multiplying it by itself. So here we have x plus 1 times x plus 1, x minus 3 times x minus 3, and so on. And the reason why we need to think of it that way, don't necessarily have to write it out that way, is to use the FOIL method to multiply it out and see what we get. So if you already know how to do this, pause the video and write out what those are as a trinomial when we multiply them out using the FOIL method. Go ahead. So as you see the results in these trinomials that are created, you notice that the name of what we're talking about actually tells you what it is. Perfect square trinomials. The first and the third terms are perfect square numbers. Okay? In other words, can you take the square root of it? Is x squared a result of something times something? Yes. X times x. And 1 on the end here is, of course, 1 times 1. All right? Plus, we got the middle term, which I'll talk about in a second. So notice at the beginning of each of these trinomials, those are perfect squares. Okay? Notice 9 is a perfect square number, 64 and 16. Okay? Also notice that the third term is always positive, because if these two terms are negatives, you're going to get a positive 9 in that case, or a positive 16 in that case. Okay? It doesn't matter what the sign is in here, because you're going to multiply it by itself, you're going to get a positive third term. Okay? Now the middle term is kind of interesting here. Negative 40k, if you take half of it, you get negative 20k. All right? And the reason is because, and the reason why we take half of it is because there's two of them when we use the FOIL method. We've got these inside ones here that give you negative 20k, and we have these outside ones that give you negative 20k. You get it twice, so it's doubled to get negative 40k. In this case, 32y is because we get 16y and another 16y. Okay? This negative 6x, if you take half of it, you get negative 3x, and that comes from that and that. So here's the pattern. These perfect square trinomials have a first and third term that are perfect square numbers or algebra expressions. The middle term, if you take half of it, it's going to be the product of these inside terms here. All right, so if we go backwards, we can reconstruct and figure out how to start with a perfect square trinomial and factor it. Let's look at some examples. All right, on this worksheet I have a number 22 showing here, and the first question is this a perfect square trinomial? If it is, we can factor it using the pattern I just described. So first of all, is 4b squared a perfect square? Yes, because it's 2b times itself. Is 1 a perfect square number? Yes, of course, it comes from 1 squared. All right, so the quickest way to factor this is you're going to put the 2b in the first position. the 1 in the second position, and then look at the sign of the middle term. It's negative 4b. Okay, you're going to have to copy that sign in there. If the middle term is negative in the binomial, of the factored answer, it's also the same. Don't forget your 2 exponent there. Now if we were to multiply that out, notice how we'd get 2b times 2b, which is my 4b squared. And I have a negative 1 times a negative 1, which of course gives me my third term, positive 1. And then the inside terms there give me a negative 2b, and the outside terms give me another negative 2b. Alright, so to double check, if it really is a perfect square trinomial, I can take half of the middle term there, which would be negative 2b, and that's the product of these two numbers inside. Alright, now you try number 24, and I have a few more examples for you to try. So on number 24, recognize the pattern that the first and the third term are perfect square amounts, and the middle term, do a little check here, half of that is 5r, and that is supposed to be the product of what we put inside here. So let's check it out. 25r squared is what we get when we do 5r times 5r. Alright, in the long form it would be like this. And 1 is, of course, 1 times 1. Okay, then we copy the sign of the middle term. So 5r plus 1 quantity squared. Alright, and to double check that the middle term is going to work out, remember that that is 5r and 5r added together, which gives you positive 10r. So my official factored answer is, since it's a perfect square trinomial, it's factored like that. And finally, number 25 and 27, those are perfect square trinomials, so factor them and try it before I show you the answer. Number 25, the square root of 25n squared is 5n, because 5n times 5n gives you 25n squared. And 4 on the end, the third term there, is a perfect square, and we know that that is 2 times 2. Make that a 2 right there. Okay, copy the middle term's sign. 5n plus 2. Now if you were to do 5n times 2, that's 10n, and then you double it to get the middle term, 20n. Alright, so that's number 25 factored. Number 27, 16v squared is a perfect square. 9 is a perfect square. Put the square roots of them in each part of the binomial. Copy the sign of the middle term. And check. 4v times 3 is 12v. Don't forget to double it, because there's 2 of them when we multiply it out using the FOIL method. And we would get 24v, a positive. Alright, hopefully these examples have helped, and thanks for visiting my online classroom, Math Class with Terry V. See you next time. Alright, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. Alright, study hard and take care.